In this problem, a driver of a car rear ends a pickup truck. Now the driver's distracted by texting and is traveling quite fast. And when it hits the pickup truck is lurched forward at a higher speed. So just to sketch what's going on, here's the car. The car has an initial speed of 16 meters per second, and it strikes the truck, which is initially moving at 12 meters per second in the same direction. So what we could do is we could note that this is the positive direction and this is the positive direction. So that's the positive direction, and that makes it the negative direction. And the final velocity of the final velocity of the truck is going to be 20 meters per second forward. So that would also be in the positive direction. So it lurches forward. And what we want to do is we want to find out what is the final velocity of the car after the collision. What happens to the car? Well, what we could do is we could use conservation of momentum, which tells me that the total initial momentum, this symbol here is sigma, means total, is equal to the total final momentum. So that expands to m car v car initial plus m truck v truck initial is equal to m car v car final. This is what we're trying to figure out. Plus m truck v truck final. And we have all the information summarized here. Now I do want to point out something about units. So when we calculate things in physics, we typically use what's called the MKS system or subsystem of the metric system. And M stands for always measure in meters. K stands for always in kilograms. And S means always in seconds. So we also here are using velocity, and since velocity uses both distance and time, the velocity units are going to be meters and seconds, or meters per second. Okay, so remember that that is the standard, those are the standard units used in all calculations. So our mass has to be in kilograms, and it's given to us in kilograms, so that's fortunate. No conversion necessary. So it's 1200 times the initial speed of 16, positive 16, plus the mass of the truck given as 2700 kilograms, times its initial velocity, which is 12, plus 12. And the car is 1200 times v final of the car, plus the mass of the truck, 2700, times the velocity of the truck after the collision, which is 20. You see the truck goes from positive 12 to 20, so it gains momentum. So the truck gains momentum, which means that the car has to lose momentum somehow, and we'll figure that out in a second. So when we do this math here, 1200 times 16, that works out to 19,200. And 2700 times 12 is 32,400. And this is just 1200 VCF plus 54,000. I think I said 100 here. 19,200, 32,400, 1,200, 54,000. So if we rearrange this, we end up getting 51,600 on the left side and 1,200 VCF plus 5,400, 54,000. And finally, we'll have the final velocity equal to negative 2,400 divided by 1,200. And our final velocity is going to be equal to negative 2 meters per second. Look at that. that means that the car bounces. Car bounces off, which means it changed the direction. And because it changed direction, it ends up having a smaller momentum than it originally did. So that takes care of question A. We've answered that. Now B says compare the initial and final momenta of the system. So B, well, we know the initial momentum right here. Okay, so right there, that's of the system. That's the sum of pi. Okay, so that's the initial momentum of the system. So we can say sum of pi is equal to 51,600 kilogram meters per second. So we're done with the initial part. Now the final, we have to figure that out. So I'll do that over here. So we can use the sum of the momenta. Let's see, how can we figure this out? If we know, the final momentum is going to be the sum of the final, which is going to be equal to the momentum of the car final plus the momentum of the truck final. And that's going to be equal to mc VC final plus TVT final. But this part right here, we've already figured that out. That's going to be equal to this number right here. And so let's plug in the numbers. Mass of the car is 1,200. We just figured that out to be -2. Right, that's over here, plus 5,400, sorry, 54,000, I don't know why I keep saying 100. So the sum of the final momentum is going to equal to, well, look at that, 51,600 kilogram meters per second. Just as we expected, because that's actually one of the first things we said. We know that momentum is conserved. So we start off with 51,600 kilogram meters per second, and we end up with the same number. So conservation of momentum, and we've proven that.